Modeling with exponential and log functions just means we're gonna have one formula essentially that I want you to use and memorize. The book splits it up into 1, 2, 3 different types of formulas. I got one. Y equals Y naught e to the kt. We even use the same formula in AB calculus next year. Y naught means y of 0, or the initial amount. If the directions say a population grows exponentially, or a radioactive isotope decays exponentially, we can use this exact same thing. If something is growing, then the K will be positive. If something is decaying, then what do you think the K will be? Negative. So, one formula. What does this remind you of, by the way?
PERT.
A equals PERT. Principal e to the RT. This is a continuous growth, right? Isn't this continuous interest compounded continuously? This is a continuous growth, right? So, now what if you ignore me and go by what the book does, you're going to have like at least, well, three different types of problems that they're going to try to tell you to do. One of them is like doubling time. If it says we have a type of bacteria that doubles every 5 hours. Find an equation that models it. By the way, it says it starts out with 25, say initially there are 25 bacteria in that petri dish. They counted 25 cells or whatever. So part A, find an equation that models it. Estimate, part B, the number of bacteria after 18 hours. No part C on this. Oh, yeah, there is. Yes, there is. After how many hours will there be 1 million bacteria? After how many hours will there be 1 million? So, the key on virtually every single problem we do is we need to find the K. That's like our first thought process every time. So, now, I'm going to tell you, I cheat a little bit to find my K, especially, I know, I cheat a little bit to if it's doubling or if it's the half-life. But if it's doubling, literally, I say if it starts out, this is my finding the K corner. If it starts out with 1 bacteria and it doubles, how much does it end up with? 2. After how many hours? 5. Literally, this is how I start out. If it's doubling, I start out with 1 and end with 2. If it's a half-life, I start off with 1 and end with a half. Half-life would be half. So what do I do now to solve for that k that's in the exponent? ln. Power down in front. Natural log of e is just what? 1. So what is my k equal to? Divided by 5. So the equation that models it is y equals, oh, initially there are 25. This is my y naught. My k, I just figured it out. ln of 2 over 5 t. There is my answer to part A. Any questions?
Yeah. So the t is being multiplied, or it's multiplied to ln 2 over 5?
Yes. The t is multiplied by that k value, right?
Yeah.
Yeah. Question, what is it? This is my cheating way. Guys, I could have started out with 25, okay? But when I double 25, what does it give me? 50. And I would have had to divide it by 25. And what's 50 divided by 25? 2. 50 over 25 is 2.
Oh, that's a 1, right.
That was a 1 and a 2. So I cheated and didn't start out with 25 and double it, okay?
Yeah, I thought it was like an L.
So does everybody follow my cheating method? I mean, I could have started out with 25, and if it doubled, it would get to 50. But I'd still divide 50 by 25, so I'd still end up with my 2. Everybody with me there? Yes. So what am I doing to estimate after 18 hours?
You plug in 18.
Plug in 18 for t.
That's a lot of
25.
hours. Or no, never mind. I'm confused.
I mean, it's not even 24.
I was thinking for C, like how many hours?
Oh, yeah.
But
I don't know. It may not be that many. 25 e to the... Everybody understands where the e to the button is? It's the second ln. It's the thing in blue.
To the whole number.
ln. I would not... I would go ahead and give me my 3 decimals.
Okay. But bacteria, you can't have half a bacteria. You just have a
I
small
agree.
bacteria.
But we're...
Well, yeah, but it's 1. Oh, well.
303 bacteria after 18 hours. So now, what are we going to do to solve? What are we looking for in part C?
How many hours?
Yeah, in other words, the what? The T, right? Where do I put the 1 million?
Why?
I put it in for Y, right?
1 million.
1 million.
Shoo.
1,000, 10,000.
What's our first step?
Divide.
No.
Divide by what?
20.
25.
I pressed clear after I pressed it.
1 million divided by 25, not 23, is 40,000. Now what do we do when we're trying to solve for that t that's in an exponent? ln. Natural log of e is just 1. Now what's the thing we're going to do? I took the power down in front. I ln'd both sides, took the power down in front, and thought that natural log of e is just 1. Guys, we're solving for the t, so what do we need to do on this next step? Divide or flip and multiply since it's a fraction. Because again, if this is on a non-calculator problem, that would be your answer, right? It's only 76 hours.
So I did do it.
So yeah, I did that nowhere.
I mean, that's only, what, 4 days?
3.
A little over 3 days.
That's about how long. Okay.
With bacteria left, unchecked, can really cause issues, can it? All right, if that doubling time is that short, yeah,
Why are you multiplying 5 or oh wait, you flipped it.
because dividing is the same as flipping and multiplying. Yeah. So, you get the idea, use our formula. If they give you a doubling time, then just use that either 1 and 2 or your amount they start with and double it, but you still end up with a 2. So that is exponential growth.
That's all?
Let's go.
Right. They like to throw in little twists. Like, this is actually problem number 4 on page 350. It's talking about a bird population. A certain species of bird was introduced in a certain country 25 years ago. And biologists observed that it doubles every 10 years. And now the population is 13,000. Okay. Now, 25. So what would this be? If we started 25 years ago, what would this be? Y of what?
Not why not? Why? 25.
Y of 25. Nice. Why not was the amount you started with, right? And it doubles every 10 years. What was the initial size? Part A.
Wouldn't this just be kind of like a half-life problem? It's going backwards. Well,
I probably would I wouldn't even think of it. I would just think of it as exponential growth. Part B, estimate 5 years from now. Estimate population
can you move the
5 years from now. Part C. Oh, sketch a graph. We're never sketching a graph. I think that's the stupidest thing. Why? It just doesn't help us.
it all looks the same?
Yeah, it all looks like this. They all look like this. Some exponential growth. It doesn't help. All right. So, part A, on many cases, is find an equation that models it. We don't have that, so we're going to have to go make our little box a little bigger, because we've got to find the K, correct? And if it doubles, is everybody good with just using my 1 and 2?
Yeah.
Every 10 years? So to find the K, ln both sides, 10K, ln of E is 1. What's our K? Natural log of 2 over 10. So our formula is y equals y naught. I don't know why I put an E. E to the ln of 2 over 10 times t. Agreed? So what does this thing here tell us then?
The current population.
So that's going to be the y, right? Now we're gonna be able to solve for y naught. ln of 2 over 10. Why not solve for y naught? 20. So this one is not looking exactly like any of the others where we're solving for the for the t in the exponent, right?
Yeah.
We're just solving for the y naught, so what are we going to do? Yeah, it's being multiplied, so how do we get it to the other side? Divide, exactly. I mean, guys, we could reduce, but this is one case where I don't reduce my fractions at all.
I hate fractions as a power.
So 13,000 divided by e to the
Literally ln right on your balls, boy. Right above stars. I see it.
I woke up at 5:30 and I was so thankful.
Anybody get it yet?
You sure so thirsty, dude?
Yeah, so I had to get water. Why would I go all the way down the stairs for that?
Anybody gotten it?
I'm about to get you one second.
What'd you get?
LeBron got it for him last time. 298. He said 2298.097.
Thank you. I mean, that's really close to like 2,300, isn't it? But I'm just gonna keep that in there. All I can figure is some of those birds were pregos. In some, various
You could just say
capacity.
like
What?
it's birds. They have nests.
Birds are actually superpowers.
Okay.
Birds are their own thing.
Anyway, so now our new formula is y equals that 22. You know what? I'm going to store that in for A. I'm going to keep the whole thing. I'm going to call that A. And go A e to what? Hit the STO button, alpha A, and don't forget to hit enter, or it won't store.
Store by right after natural law. When you press it. STO.
5 years from now, guys, what's that going to be? Actually, we can cheat on this one too. 25 years plus 5 is 30, right? Or let's just restart it and use the 13,000. I'm gonna get y'all to test both of these.
What?
I'm gonna get y'all to test both of these and see if they come up with exactly the same answer.
So we just plug this in. Don't tell me what to do.
Oh, geez.
Don't do
Put 13,000 to that.
It's above the division. Wait, which E?
E to the button, second ln. So I got 18,384.776
Yeah, I did it wrong.
using this method.
The top one I got the same.
I got
13.
I got it
832,000.
off because
E to the
I just did.
I think it might be 10 times 13.
It's the same.
Oh, you
all my stars. Looky here. exactly the same.
Yeah, I did it wrong. I
That's
got
what it's
832.
It's magic.
It is magic.
That's a pretty star.
So guys, are y'all following? We can restart it wherever we want to as long as we use that same growth rate. And we would change the t-values, right? Does that make sense?
Yeah.
All right. It doesn't make sense? All right. So let's look at an exponential decay. You have, in medicine, there's an application like, medicine has a half-life, or the amount of time it takes for half of it to dissipate in your body, right? And so that's where doctors have to be careful about dosages and how many times a day you take it. And that's why you need to be careful about where you take it to try to keep that level in your bloodstream, as even as possible. There's also exponential decay in radioactive things, right? Carbon-14 dating is based on radioactive decay. But guess the formula that I'm going to use?
The same one.
Y equals Y naught e to the KT, right?
Yeah.
And so let's look at number 18. Number 18 on page 351. Here it says radioactive cesium
I love
has a half-life
Not thinking that.
of, oh, that's cesium-137, sorry, has a half-life of 30 years.
That's very short.
Yeah, it feels like very short. Compared to like carbon-14, it's like 1,900 and something. I don't remember how many years.
Uranium is Eureka.
So, and suppose we have a 10-gram sample. Now this part A gives you some random negative thing, and part B gives you find m of t equals m naught e to the negative kt. Our k will be negative, so our part A is use our formula. So ignore the directions if you see it with some random m naught, n naught, and a negative k, okay? Use this function. So find a function that models it. Our information. So what's our goal initially? Our goal is to find a k. Half-life, if we start off with 10, we end with 5. E to the k times how many years? 30 years?
Yeah.
Divide by 10, and what do we still get?
1/2.
1/2. So I could have cheated and started with 1 and ended with a half, right? Oops, 30k. Divide, I'm sorry, ln both sides, right? 30k equals ln of 1/2. What does my k equal? Ln of 1/2 over 30. And just to show you, natural log of 1/2 divided by 30. Natural log of 1/2 divided by 30 is a negative number. Okay? And by the way, since I took this time, I could store that in for k, couldn't I? And just use k for the rest of the time. But maybe not. We'll just keep it ln of 1/2 over 30. So our function will be y equals y naught, which is 10 given, e to the k, ln of 1/2 over, was that 50? 30, sorry. An example of me not being able to read my writing. Part B says how much is left after, it's actually part C, but after 80 years. How much is left after 80 years? What are we doing there?
You plug in 80 for T.
Plain old plug and chug, right? 80 for the T, right? Everybody plug and chug. Because there could be a little issue on the way you plug in your exponents. I just want to make sure you're getting it.
Yeehaw.
You did not just do that.
You did not just do that, Aiden. There's no way.
How dare you?
How dare
Hey,
you?
plug it. I'm trying to write it down correctly first.
That's how many?
The why not was given.
Yeah.
This is your why not.
Oh, I did 2.
This got messed up.
I got it.
What'd you get?
The formula, how to do it.
1.5749
Is that wrong?
grams.
I plugged in the wrong number.
What'd I do wrong?
Taste, plug it in.
Oh, I put 85 or 80.
There you are.
Why? How do you mix up an 80 and an 85?
Because I was stupid.
Yeah, minus 7.
The last question they ask, I'm looking at their wording. After how long will only 2 grams of the sample remain? How long will it take to reduce to 2 grams? What are we doing on this one?
2
Equals 10 ln of 1/2 over 30. Solve for the T, right? Stop fighting over the calculator. There's 2 more over there. Hand him another one.
He's deleting my answer.
His is right there.
Okay, so don't attack humans.
He
Humans have
deleted my answer.
will.
It's right there.
Humans have will too.
Right there.
Everybody following what I did? Divide by 10. Isolate that. What's our last, or next to the last step? ln both sides. Bless you. Power down in front.
Divide by all that and jump.
Natural log of E is 1, right? Well, in this case, I'm going to flip and multiply by that junk.
Hey, you just got told.
I mean, you're welcome to do it as division as long as you're careful with your parentheses and junk.
Divide by that, Jim. Stop copying.
Wait, you're still dead, or are you okay?
Nice.
That would equal 69.65.
69.657.
I just said that case.
Round it to at least 3 decimals for me. All right.
Zach.
All right.
All right, good morning. Good morning. I thought
So, legit, I'm stretching this out to another day, and we're gonna hit like some pH and the magnitude things, you know, those formulas that y'all came up with at the beginning. We're gonna do a few of those, but I'm only assigning, because these take a while. You know, we've only essentially done 3 examples, so they take a while to develop.
It's
Do
gonna be
what?
a 5 homework.
You don't understand it, or you do?
Tough luck.